For us, the dream begins like this: designing, creating, building. Then we take off, invisible like the wind. And suddenly the future passes before our eyes. Only it's not the future, it's the present. And our dream has become reality. And just wait till you see what's next.
For more than 50 years, Lockheed Martin's Skunk Works has been at the forefront of development of some of the industry's earliest and most innovative unmanned aerial systems, pushing the boundaries of what is possible. Stealth, persistence, materials, and altitude. Partnership and performance define us. For unmanned systems we can talk about, and those we cannot. Today, Skunk Works is focused on driving the development of key capabilities that will define the next generation of unmanned aerial systems. Integration of proven technologies, leveraging manned and unmanned operational systems to maximize reuse of hardware and software. 24/7 persistence that is affordable, reliable, and provides continuous, actionable intelligence. Full-spectrum mission utility to make possible operations in any scenario and in any environment. Advanced signature control featuring cutting-edge multispectral stealth, communications, and bandwidth management to defeat detection and enable mission success. Open systems architecture designed to reduce system integration time and cost and make possible the affordable reuse of hardware, software, and systems. And true autonomy. Multi-vehicle control by a single operator.
reaching the microphone are changed into impulses of electric current.
No need to worry about your pre-recorded music tapes being accidentally erased. It can't happen.
What if you could sling lift 13,000 pounds of howitzer straight into the sky and carry it farther than any helicopter ever before? What if you had more than double the cabin volume of a UH-60L Blackhawk, with more cabin height and width than a V-22? What if, with a crew of 4, you could carry 12 NATO litters, or haul a useful load of well over 8 tons, then deliver it 50% faster than any helicopter made? What if, with an extended combat range, improved loiter time, and a hoagie of 6,000 feet and 95 degrees, you could deploy and protect 14 battle-ready troops, molly packs and all? What if 2 side doors measuring 40 inches wide plus a ramp at the rear equaled 3 superb fast rope ports for special ops needs, and that ramp opened a gaping 6 by 6 foot hole to give you unparalleled access for rapid load in and load out? What if the enemy had no clue? Are you just troop support or a lethal attack aircraft capable of both refueling and reloading armaments while airborne and in mid-mission? What other vertical lift aircraft does that? What if utility and attack versions shared over 90% common parts, cured the headaches of logistics, and made the supply to demands of maintenance a low-impact effort? What if its time-tested technologies of fly-by-wire controls, coaxial rotors, and ducted fans not only provided more agility with a highly maneuverable, low-inertia design, but also quieted the flight, and that smoother flight, now less stressful on critical parts, carried the day to far more reliability? What if the best engineers, unequaled in the successful development of advanced rotary winged aircraft, teamed with top-tier national aerospace suppliers who were eager, ready, and willing, joined together in a company that could start the build of that aircraft today? What if they came together for one aircraft, one with over 80% of a tilt rotor's flat-out speeds, but for less than half the cost of a V-22? Think of it, a shipboard-compliant aircraft with a smaller footprint than either a Blackhawk or tilt rotor, yet one with more payload, better agility, greater range, higher endurance with speed and survivability, but requiring much less maintenance and lower costs than ever before. What if all these uncompromising attributes, these spectacular characteristics, scaled up or down to future flight needs? What if, for every dollar spent, it produced the greatest value in a vertical lift aircraft ever known? What if it became real? What would you call it? We call it an innovative compound coaxial helicopter. But you can call it the future of vertical lift. From the team at AVX Aircraft Company, Flight Advanced.
As the U.S. military shifts to smaller, more distributed combat units, transporting and resupplying troops in rugged, austere terrain has become a major challenge. To meet this challenge, DARPA initiated a program in 2010 to demonstrate a 4-person vertical takeoff and landing, or VTOL, flyable, roadable vehicle to provide the warfighter terrain-independent mobility. The Lockheed Martin team, which includes Piasecki Aircraft Corporation, has taken that concept a step further to produce a multi-mode autonomous VTOL delivery system called Ares. The flight module is a fully self-contained VTOL unmanned aerial system with its own power system, fuel, digital flight controls, plus UAS command and control interfaces. The twin tilting ducted fans are designed to provide efficient vertical takeoff and landing, with rapid conversion to high-speed cruise flight. The closed ducts help protect ground personnel from the rotating props. Ares VTOL flight module could adapt to multiple missions with interchangeable payloads, offering new capabilities and enabling new operational concepts. The ducted fan design enables a landing zone half the size of a typical helicopter with a similar payload. Using simple, intuitive control interfaces such as military smartphones or ruggedized tablet computers, soldiers could program missions in the field in real time. Advanced sensors and digital flight control systems could allow this next generation of VTOL UAS to autonomously identify landing zones, avoid obstacles, and complete landings, all without needing inputs from a remote pilot. A full-scale flight demonstrator is in development now to validate the flight module's ability to perform vertical takeoffs, hover, make smooth transitions between hover and forward flight, and meet predicted flight performance. After the prototype proves that it can fly as predicted, additional tests with a variety of payload types may be performed. Ares has the potential to dramatically change the way troops are transported and resupplied in rugged, austere terrain. Together, we are transforming the next generation of delivery systems to more efficiently support the warfighter in the field.
I work at the Skunk Works, and it's got a legacy of doing the things that people don't think can be done. Flying very high, flying very fast, making airplanes invisible to radar. Where do we go next? That's always the fun question.
Right now our airplane designs are very reductionist. We have fuel over here. We have the cockpit. We have the engine. They're all separate parts. What if we could integrate those parts together in a holistic manner?
Can we do things like embed the carbon nanotubes to make conductive structure so that information doesn't flow through a wire next to a structure, but literally flows through the structure?
We'll be able to grow or make a structure that, say, is the skin of an aircraft, that inside of that is also contained the sensors, or the energy storage, or many different multiple functions.
New materials that are on the lab bench right now, they can literally change shape on command. They can become almost a muscular material.
We could have an airplane that optimizes its shape for the different flight conditions it's in.
There's definitely a lot of amazing technology that's going on with the Lockheed Samurai, based on a small maple seed-like looking device. The fact that we can package enough energy for something like that to fly and still carry a sensor, a camera, enough control capability for it to fly is amazing to me. As we go forward, we're going to find new ways of using these unmanned vehicles.
They'll probably be autonomous, so they'll be like UAVs, but carry cargo around where there are currently no infrastructure in place.
We may have small swarms of small vehicles interacting with a larger vehicle that basically combines the information from that swarm. So maybe one vehicle flies a small distance and another vehicle learns from it and knows which way to fly.
Probably what makes sense is a heterogeneous swarm. One where not every element of the swarm is the same. Some elements of the swarm carrying sensors, some carrying other types of electronics. So it's an adaptable system that can adapt to a changing environment and a changing future that is difficult for us to predict.
The true value of research is not in the answer you get that you knew you were looking for, but the answer that you find that you didn't know to look for.
Fans of the movie The Avengers may remember a flying aircraft carrier. Now, officials from the United States military's Defense Advanced Research Projects Agency, or DARPA, have expressed interest in developing their own flying aircraft carrier that can launch a fleet of drones. Dan Patt, a DARPA program manager, is quoted as saying, "We want to find ways to make smaller aircraft more effective, and one promising idea is enabling existing large aircraft with minimal modification to become aircraft carriers in the sky." They are accepting ideas from companies, universities, and organizations that want to participate in the development of a flying aircraft carrier. The proposals have to be 8 pages or less and outline operational concepts and mission applications, along with comprehensive costs to existing conventional technologies. During the 1930s, helium-filled dirigibles were briefly used to launch planes, but the early flying aircraft carriers crashed shortly thereafter, which led to the U.S. Navy ending that operation.